Hello and welcome. Today, we're going to pull back the curtain on rest. If you've ever wondered how all the different apps on your phone talk to each other and to the internet, well, the answer is almost always rest. And look, getting a handle on this is an absolutely essential skill for building the kind of scalable microservices you're going to run into in the corporate world.
So think about it for a second. How do services like Netflix and Uber just work so seamlessly? Or how does your banking app securely talk to the bank servers? Well, the secret sauce holding a lot of this together is a well-designed REST API. And in this breakdown, we're going to find out exactly how it works. So here's our roadmap. We're going to start with the basics of what REST even is, then walk through its core principles, and then we'll get into the actual tools developers use. And most importantly, at the end, we're going to connect all of this directly back to microservices, so you can see exactly why this architectural style is so dominant today. All right, let's get right into it. The term REST gets thrown around all the time, and honestly, a lot of the time it's used incorrectly. So what is it really? Let's get a precise definition. Okay, this is the single most important thing to get right off the bat. REST is not a specific technology or some kind of rigid protocol. It's more like a philosophy, an architectural style for designing networked applications. At its heart, it's a set of guiding principles that, when you follow them, lead to systems that are way more scalable and easier to maintain. So, this style was defined by a guy named Roy Fielding in his PhD dissertation way back in 2000. His core idea was actually pretty simple. A well-designed API should behave exactly like you browsing a website. You start on one page, and that page gives you links to the next possible actions you can take. Every click is a new state. That right there is representational state transfer in action. So if REST is a philosophy, what are its rules? Well, for a system to be truly restful, it has to follow 6 guiding principles. And these aren't just suggestions, they are the constraints that give REST its power and its scalability. Let's focus on the 2 most important ones here. First, stateless. This means the server completely forgets about you after it answers your request. Every single request has to contain all the information needed to process it. Now, why is this so great? Because it means any server can handle your next request, which makes scaling up to millions of users much, much simpler. Second, a universal interface. This just ensures that everyone is speaking the same language, using standard web technologies. That simplicity is the absolute key to decoupling different services from each other. Okay, so we've got the principles, but what do we actually build with? The foundation of any REST API has 3 main building blocks: resources, URIs, and methods. A library is actually a great analogy here. In REST, we think of everything as a resource, a user profile, a product, even a search result. They're all resources. And just like every book in a library has a unique catalog number, every resource has a unique address called a URI, so we know exactly how to find it. Now, the real elegance of REST is that it doesn't reinvent the wheel. It just piggybacks on the standard verbs that are already built into the HTTP protocol that powers the web. These methods map directly to the 4 basic operations you'd ever want to do with any piece of data: create, read, update, and delete, what we call CRUD. This makes REST APIs incredibly predictable and super easy to learn. Now, here's the thing. Not all APIs that call themselves REST are created equal. The Richardson maturity model gives us a framework to measure just how closely an API actually follows the principles of REST. Think of it like a ladder, where each step gets you closer to the full power of REST. So let's quickly walk through its 4 levels, starting right at the bottom, level 0. Level 0 is what's sometimes called the swamp of POX. This is where you're using HTTP, but only as a dumb transport tunnel. You've got a single web address, and you're just sending messages that tell the server which function to run. This is basically a technique called remote procedure call, or RPC. It works, sure, but it completely ignores the power of the web's architecture. Level 1 is a step up. Here, we start thinking in terms of resources. Instead of one endpoint for everything, we have multiple URIs, each one identifying a specific thing, like an appointment slot on a doctor's calendar. We're still just using post for everything, but at least our system is better organized around nouns, not verbs. Level 2 is where most of the APIs we see out in the wild live. This is the sweet spot where developers start using the HTTP protocol as it was designed. GET is for fetching data, POST is for creating it, and so on. We also start using standard HTTP status codes like 404 not found or 201 created. This makes the API much more predictable and robust.
But there's one more level. Level 3 is what Roy Fielding would call truly restful. This is the glory of REST, and it introduces a powerful concept that makes APIs self-discoverable and dynamically navigable.
This final level is all about a concept called HADOS. Now, it's a complicated name, but the idea is simple. Just look at the two responses. The level 2 response on the left just gives you data. The level 3 response on the right gives you the data plus a map. It includes links to the next possible actions, like paying or canceling. This means the client application doesn't need to know the URLs ahead of time. It discovers them dynamically. This massively decouples the client from the server, making the whole system more flexible. Okay, so we've climbed the ladder all the way to the glory of REST. So why does this matter to you? How does all of this connect to building applications with microservices? As you can probably see, the principles of REST are a perfect match for a microservices architecture. Because REST is stateless, you can scale each service independently without complex session management. Because of the uniform interface, a service built in Java by one team can talk seamlessly to a service built in Python by another. This level of decoupling is exactly what you need to build the large, scalable, and maintainable systems that are common in corporate development. So, as you go on to design your own applications and your own microservices, here's a final thought. Are you just building a level 0 API that gets the job done? Or are you aiming for the glory of a truly RESTful system? Using all the principles, right up to level 3, can make your systems more resilient, more scalable, and easier to evolve over time. It's something to think about. Thanks for watching.